Hey everyone, Krishna here, and I welcome you all to this channel. So let's solve this weekly contest 483's last question, which is minimum cost to merge sorted list. Initially, I thought to not cover this problem, but anyway, before solving this one, right, make sure to solve some of the bit masking related questions like generating subsets and all, and then you can start looking into this one, okay? Because without understanding of this bit masking concept, you cannot easily understand what I'm trying to say here at this point in time. So I'll avoid to explain all basic stuffs again, whatever concepts regarding this bit masking and all. Make sure to first understand it, look into this solution, okay? So let's see what problem is basically saying. So we have basically given 2D list. Okay, I'm not reading this problem statement. So in this list, we just have to merge all these lists that are available in each index, and at the end we have to generate one single list. While merging, we get a cost. Okay, so whenever we are trying to merge two lists, okay, we will be going to get a cost. So the cost is calculated as whatever the length of first list that we get it, length of second list, and then absolute value between median of A and median of B. Okay, so this is how we get a cost. So if we look into this solution only, so let us say that first and second list we are merging. So let's name them as A and B. So if we are merging them, the first list length is basically 3, seconds is 2, and median of this first list is basically 3. So here we are not talking about mean and median. So this midpoint, whatever we get it, that is the median. And for this second, it is 2. So we just have to get all these values, and we have to calculate this cost. By calculating this, so we are getting 6 as a value. Now these two lists got merged. Okay, so we have to make sure that while merging they are basically in a sorted order. So we got our this new list. Okay, so now this list becomes this way. Okay, we merged first and second list. Now again we have to merge these two lists, right? So again, length of first list is 5, second list is 3, median is 3, 7, and the cost is something we got 12. Okay, so previously we got 6 and here we got 12. So in total 18 is the answer that we are getting it. So we have to make sure that when we merged and we got one single list, the cost that we are getting it, okay, it should be minimum, right? Because there are bunch of possibilities, right? Like I can merge first and third for initially, and then whatever result I got it, I can merge it with second list. Or even I can merge this second and third first, and then whatever result I got it, I can merge it with first. And if you try to perform that, obviously the cost is going to be high. So it is better to merge first and second list, and then whatever result that we got it, we can merge it with last. Okay, so here we have a bunch of possibilities, right? So we can merge any of them, and then we may have to we just have to look for minimum cost, right? So there could be bunch of possibilities. We may have so many different solutions. So how can we solve this one, right? That is the question, because brute force, simple brute force approach won't work here at this point in time. Obviously we have to make sure that we are using some optimization. We are trying to store some of the values, some of the pre-computed results in such a way that we can easily solve this one. Okay, if we look into these constraints, we see that this list length is basically 12, and each list length may go up to 500. So by looking into this one, so we can now think of like, okay, brute force may work, but we have to make sure that we have to pre-compute some of the results, right? Because by performing these different list merge, right, obviously we have to compute every time the median of those lists. Okay, so again, those solutions median, whatever two different lists that we are merging, we may have to use it again for some other computations as well. So there we can think of like we can try to compute these medians first, length, whatever two lists that we are merging, their length. And obviously this length is so less, like list length, we can obviously use bit masking. Okay, so we can create mask because it goes all the way 2 to the power of 12 different subsets that we can get it, right? So yes, so obviously we can use bit masking here to pre-compute these results, and then we can try to generate the cost. Okay, so first let me connect the screen, and I'll discuss about how we can generate or pre-compute all these medians, and then how we can try to solve this one. Okay, let me connect the screen first. Okay, I hope screen is up. So see here, this is the list that we have. Okay, and what we have to do is we have to simply merge them, and we have to generate the cost. So see, as I said, like we can use bit masking to pre-compute results, some of the results of medians and lengths, whatever list we are considering. and then based on that we can start calculating the cost. That is our thought process here, right? So how to pre-compute medians? Okay, that is the question. So see, in bit masking, right, what we basically do is if we have, let us suppose for now let's just consider this as A, this is B, this is C. Okay, so these are our list, so I just name them as ABC. So if I try to generate different subsets, okay, subset in the sense like list whatever different values that we have, that can be a subset as well, like ABC, this is going to be a subset. Even individual element can be a subset, or without any elements also can be a subset from this particular one. Okay, so now we have different possible subsets we can get it, right? So first is like A individual can be a subset, B can be a subset, C can be a subset, then AB can be a subset, AC can be one, and then BC can be another one. Lastly, like ABC itself can be a subset. Okay, so these are bunch of subsets that we can get it. And obviously when we are trying to merge this list, okay, so we may try out like A and B. AB's first we are trying to merge it, then we will whatever result and reason that we got it, we try to merge it with C. Or even AC we can try to merge in, then we will try to merge whatever result we got it with B. Okay, that is something what we are going to do it here, right? So what we can do is we can use here bit masking to generate all different lengths and median of these subsets. Okay, so first for single A, its median and its length. For this one is this one. So whatever median and their length that we are getting it, because those are the values that we are required to calculate the cost, right? So what we can do is we can use here bit masking. So here if we have three such subsets, I mean three different lists that we have inside our main list. So there are like 2 to the power of 3 possible subsets that we can get it, right? So it is like 8 different possible subsets we can get it. Obviously 8 minus 1 if we are not considering empty list. Okay, so here you see it, right? Like this A, B, C, A, B, A, C, A, B, C, and A, B, C. These are in total 7. So 7 possible subsets we can get it. Apart from this, we are not going to get any other subsets if we are ignoring for empty subsets, and we don't have to bother about empty subset as well. So what we can do is for in bit masking, what we do is like whatever the mask that we are considering. So here three different say values that we have, right? A, B, C. Like these are the list we have. So if we are considering this A in our mask, okay, in our mask. So what we do is we mark it as the bit basically going to be set. Okay, and for this B it is going to be 0, for this C it is going to be C. So this value basically represents A. Okay, now if I talk about B, only B is the list that we are considering. Only B list is something what we are considering. Then in that case, all other bits are set as 0 and this one is going to be set bit. So this represents B. For AB, it is like these are set bits and this is like not set. Okay, because that is not part of this AB, right? Obviously, the same goes with AC. So this and these two bits are set and this is not set bit. For BC, it is like these bits are set and this is not. So this is BC. Then ABC, for ABC, like all bits are set. So 1 1 1. Okay, this is how we are basically creating the mask of this list. Okay, so now based on this, like what we can do is we will start a for loop. We are starting from I equals to 1, because for 0 we are not considering, and it goes all the way to I equals 1 left shift of n, whatever n value that we have. That means like 1 left shift of 3 means like it is going to be to the power of 3 only. Okay, I think that is the main idea. Okay, so you should have all these different ideas that what I'm trying to discuss over here. So yes, so we have these different bunch of possibilities, like starting from these different masks that we have, right? For each mask we'll try to compute their median and their lengths, so that we can reuse them later and we don't want to recalculate these values again and again. Okay, so what we do is basically here we'll start from 1. So 1 means like it is represented as 1, so it is represented as 0 0 1. So 0 0 1 is basically representing this C. Okay, 0 0 1, it basically represents C. Okay, so what we basically do is when we got this one as a mask. Okay, so this I basically it is going to be a mask. Okay, so these are different masks, like 1 1 0 1 0 0 0 0. So in this mask, like whatever the mask value that we are getting it, we just check that which particular list we are pointing out. Okay, which different list that we are pointing here. Okay, if mask is like 1 0 1, so it is like A and C. these are the two lists we are talking about. So A list is basically this one and C is going to be this one. So these are the two lists that we are considering. So when we start from 1 and we go all the way to I less than this one left shift of 3, that means we are covering all these different possibilities. For each different possibilities, we just have to get the median and length. That is the whole idea, right? So how we can get it? Simply like for this first mask, we will check that which particular list that we are talking about. So again, we have to run a for loop and it goes all the way from 0 to the list that we have, different list like this one, this one, this one. And we simply check that whether this particular mask, in this mask, which list we are talking about. Okay, so this second loop is like for j, and this list we will iterate from there, and we simply this particular mask that we have, right, I, and simply we check that whether this one left shift of whatever this j value that we are having. Okay, so whatever this list that we are talking about, okay, if it is, if that particular list is something what we are considering in this particular mask, then we have to simply get the length of that particular list, and we have to simply consider all the elements that are available in that list. Okay, to merge, make sure that we are merging both different lists. Okay, so when we are iterating through this mask, okay, that was the outer loop, right? So in that case, let us suppose the mask is like 101. Okay, this is in simply like the value is basically this 4 and 1 5, so it's 5. So for 5, what are those lists that we are considering? The first is like 1 2 3. Okay, that is our first list, and the last list, which is 6 7 8. Okay, so what we have to do is we have to simply, when these particular mask, that is something what we got it, so these two lists, that is something what we are talking about. So what we can get is its length is basically 3, its length is basically 3, its median is basically 2, its median is basically 7. Okay, now simply we have to get the total length, right? When we merge these two lists, its total length is going to be 6. So this list plus this list size is basically 6. So what we are trying to do, we are maintaining median and length. Okay, so when we merge these two lists, what is the median? So 1 2 3 6 7 8. When we merge, the median is basically 3. Correct, the median is basically 3. So its median is basically 3 and its length is basically 6. So these are the values that we are storing against the mask. So its mask is like 101. For this particular mask, the median is basically 3 and length is basically 3. Length is basically 6. So how to get the median? We simply, what we do is we will maintain another array in which we simply add these all the values and then we sort them. Okay, because the size is so small that we can perform this operation. Okay, so we can simply get all these elements in another array. We can sort them. After sorting, whatever the median mid value that is there, once we sort this entire list, when we merged, whatever median value that we are getting, that is going to the median. So for this particular mask 101, when we are considering A and C, the median is basically 3 and its length is 6. Okay, so again, like same different possibilities that we have, right? Like we are running from this mask all the way different, whatever all these different combinations, I mean values that we are getting it, for all of them we will simply do same operation. Okay, through this way what we are doing, so we are getting the median and their length. Okay, and what we do is another thing is, so for each mask, okay, so let us suppose how many set bits that are there. So we will try to group them in particular set bits array. So what we do is, like, if here two set bits that are there, right? So this a b a c b c, these are having two set bits. Correct, set bits means like how many ones that are available in particular binary formation. So two set bits that we have. So what we do is we will maintain for two set bits, all different masks we will store it. Okay, so this you will get it, like what, why we are doing it later. So this grouping is something what we are doing it. So these three set bits having two set bits elements masks, we are storing it in particular array formation. Okay, so all this a b AC and BC, these are available in this particular set. So we will come across this one first, like all these things are something what we are pre-computing them. Okay, so let's first solve this code till this point in time, and then again we will discuss about it. Okay, so this pre-computation is something what we will first solve. So the first thing what we have discussed is we will be creating a median which is having size of mask. So the mask size is basically int then basically let's get the length of this particular list. Okay, and int size, it is going to be list list. So size is something what we are calculating, right? So one left this is the mask size. Okay, so this size is something what this median we are creating about. Okay, so let's get it in form of long, because we may get out of bound if 64-bit is something what we are hitting. So first is long, then this median what I have said. Okay, next is like length. Okay, so this length is also in form of long having size. Okay, for each different subsets, okay, sets we are generating, right? So whatever different subsets that we are generating it, for them whatever median and length that we are getting it, that is something what we are trying to store. Okay, another thing is like when we are merging list to get the median, right, we have to generate the array. So I don't want to again and again, like we can do it, there is no problem in that, but let's just get that array here only. So new long, when we are merging two different arrays or multiple arrays in that particular mask. Okay, so new long, its length is going to be whatever. So here the when we merge all different lists that we have, so total length is something what we have to get it, right? What I can do is here int total length equals I can simply get all the lengths that we have in this list. So list arrays, let's stream them. Arrays dot stream this list dot just get that to map L tends to L dot length. Let's get that length and sum them up. This way, like total whatever this first list length, second list length, and third list, we are just summing them up and we are getting total length. Okay, so this generally we are using it for merging different lists in one particular area. Now we can run a for loop for int mask, which is basically starting from one, because we don't have to bother about the mask I mean 0. We don't want to consider none of the list, right? Like that is not the case that we are looking out for. So mask is basically one, and it goes all the way to size and mask plus plus. Now inside this let's run another for loop, and here before running the for loop, right, so this mask and in the list, like which particular list we are considering in that particular mask, so that is the for loop that we are trying to run here. So here the next for loop is like it starts from first list. Okay, int I equals 0, I less than n, I plus plus. Okay, now we basically just have to check if this particular any particular list is part of that particular mask. Okay, so what how we can do is like mask and one left shift of I. If it is basically equals if it is not equals to 0, that means that particular list is a part of that mask. Okay, so we have three different lists. Our mask is 101, 101. So in that case, first list is part of that, second is not part of that. When we perform this mask and that one, so mask is like 101. So when we are considering any particular list, so zeroth index list, whatever zeroth index list that we have, one left shift of 0. When we do that, okay, so it is like one left shift of 0. Okay, so one basically gets shifted to this particular one. Okay, zeroth index by 0. So it is like 001. Okay, one left shift. And when we are performing AND operation, okay, when we are performing AND operation, this value basically uh, obviously it is equals to 1 if we compute it, which is actually not equals to 0. That means like if we are getting 0, when we get 0, if we are just simply considering 0, I mean middle list, which is not part of that mask, so in that case only 0 values and not we get it. I hope you get these things. You should be already having awareness of all these things. Okay, I shouldn't be talk about all these things at this point in time. So now when we perform this operation, if it is a part of that mask, then only we will get all the elements in that particular list. Okay, so int val from this list of that I, and what we can do is in the array, let's get some outside of this one, right? So int should be, let's get the length. Okay, because in the array we are putting all different lists into that particular array, so length is basically 0. So length plus plus this values and what we are adding it. Okay, so now the array is basically getting generated, so all different lists that we are that are part of that particular mask, those elements are available in the array. Once we are done with that, okay, all different lists we added into this array, we can simply sort that array. Arrays dot sort that array 0 to whatever length that we have. Okay, so we have to make sure, because sometimes this total length is huge, right? Like 0, 0, 0, 0, whatever extra zeros that are part of that these which are not part of that mask, they may get occur. So we have to make sure whatever 0 to length that we got it, those elements are something what we have sorted. Now let's update that into the median. So median is now simple, like median uh, median of this mask. Okay, so for each mask we are storing the median, right, is going to be equals to this array of whatever length minus 1 divided by 2. So we just need to get median mid element of that sorted array. Okay, so that's how we can get the median, and length is basically equals to length of mask equals to whatever length so far we got it, that is the length. Now next is like again we discussed about grouping all those elements, right? So that is something what I have to discuss. So let's get how many set bits that are available in this mask. So set bit is also we are tracing out. Set bit is equals to 0, and if at any point in time if this condition is somewhere we are entering, so set bit plus plus we can do it. Okay, so we got how many set bits that are there. So again, like we have to maintain another what I can do is like I can maintain simply a list of integer array list. So it is like mask to bit. Okay, so bit to mask. Okay, so for each bit all different masks that we have, uh, okay, those values are something what we are storing it. Okay, array list, and let's add first I equals 0, I less than, its length is going to be n plus 1, less than equals to n I plus plus, add all different objects, mask of I equals new array list, and whatever the I mean grouping that we are doing it for this bit to mask. In this one, set bit, whatever set bits that we have for that one, what we are doing is we are simply adding in that one, we are adding this mask. Okay, whatever different mask that we get it, either it could be like for two set bit, like it is going to be AB, AC, and then BC. So these are something what we have grouped. Okay, so while traversing them, it is pretty much easy to consider those set of groups only. Okay, now so far we are done, like we just pre-computed this median and length. Now next goal is we have to calculate the cost. Okay, okay, again let's solve how we can calculate the cost, right? See, obviously whenever we want to actually merge ABC all together, we have to initially solve either of the best two different lists, which is basically going to generate us minimum cost. Okay, and again here we have to generate all different possibilities. Okay, it is not like we simply can get the cost and all. So we will basically go through all different possibilities, all different subsets that we have, and based on that whatever best result that we got it, that is how we can get the cost. So initially what we do is like this particular thing we already generated set bits. We will start from two set bits. Okay, single set bit, obviously that means like a single list is something what we have, and its cost is going to be 0 at any point in time, right? So at any point in time, whatever a single list that we have, its cost is going to be 0. If only single list is something what we have given, right, that list itself is an answer. So we are not merging anything. When we are merging any two lists, then only cost comes into the picture. Correct. So we will start from two set bits. Okay, so we are simply solving it top to bottom. Okay, like we are starting from this two list. When we merge two different lists, what is the answer that we are getting it? Okay, the cost that we are getting it. Already we have median and its length, so that way like we can easily get the cost. Okay, then for three set bits we will try to generate all different solutions. Okay, so yes, there are so many possibilities that we can get it. So that way like we'll start first generating two different list costs. Okay, and then whatever cost that we got it for those two different lists, minimum cost that we got it, that is the answer that we are going to store. Okay, there we can use DP. So all these different masks that we have, for them we will create a cost array. Okay, so here we will create a cost array which basically has size from uh, one left shift of n. Okay, so whatever values that we have for different these different masks that we have, their cost is something what we are trying to store inside here, and at the end whatever the last cost that we are going to get it, like one left shift of n minus 1 in that index, the entire list minimum cost is something what we will store it. So this is our DP array. Okay, so now we will start from two set bits. For single set bit, obviously the answer is going to be 1. If we just have given one list, the answer is obviously going to be 0, right? So in the cost array, for cost of these different bits, like for this one, okay, for this one, and then this one and this one, because this is basically storing all different mask answer. Okay, for this one, this one, this one, the answer is obviously going to be 0. Initially the cost array is having 0 values. Okay, so initially all different mask value is going to be 0. So when we start generating answer from two set bits, okay, so these different masks we have. Okay, so that's why we actually combined them. Okay, for two set bits, what are different masks that we have? So we will again take out all those masks. So initially we pulled this particular mask, okay, which is uh 0 1 1. So inside this, which two list we are considering? It is like obviously for 1 1, this is B, this is A. Okay, this is B, this is A. So 0 index list and first index list is something what we are considering. Okay, so in this particular case, when we are considering what is the cost that we can get it, obviously the cost is going to be for this particular A. What is the median? It is 2. Its length is 3. So we simply in the cost, we can basically get the cost, right? So in the cost, what we can do is whatever cost of A plus cost of B plus length of that particular mask. Okay, this mask, for this particular mask, the length is obviously it is going to be 5. Okay, length. Okay, see, cost is something what when we are merging whatever different results that we are getting it, those costs are something what we are keep on maintaining it, right? So you notice that when in the first case only, so here, when we merge two different lists, its cost is something what we got it 6. Now we can get that cost, and again when we are merging with this B, its cost is also we have with us, like it is going to be 0 obviously. So different is when we merge them, their length obviously total mask length for this particular going to be A and B, and this is the C list that we have. Okay, in our term, like how we are solving them. So for AB, their length is already there with us. For B, for C, its length is also there. So when we are merging both of them, the mask value that is going to be 111. For 111, the length is already there with us, which we already calculated. So that cost is something what we can consider. Median is already available for each of these different masks. So those values we can get it. And cost of AB, that we got it, because obviously the cost of AB is something what we don't have. Cost of AB is something what we don't have, and which we are calculating for AB. The cost is something what we are calculating now. Okay, so cost of A, cost of B, length of that particular mask plus here math dot ABS absolute value between this whatever median of that A. Okay, median of A. Median of A means like we can simply get this one, right? 0 0 1, which is obviously a mask out of this. So for this particular one, what are different possible subset, right? Those are like either it is going to be B, which is 0 1 0, and A is going to be 0 1 1. So these are two different sets, subsets. This is B, this is A. So we can pull them out easily. We can get these values, B and A's values. We can easily get them. So now once we get them, we can simply get the median of that A, median of this B. Okay, from this particular storage, we can get those values, and we are done. Like we basically calculated the cost of this particular BA. Okay, once we calculated cost of BA, next mask is this one, this one. So this way, what we are trying to do, we are trying to get cost for AB, we are trying to get cost for AC, we are trying to get cost for BC. Once these costs are done, now we can move simply for cost, calculating cost for three set bits. Okay, two set bits when we are once we are done, three set bits cost is something what we are calculating. So here the list size is basically 3. If we have multiple, then 4 set bits cost is something what we are getting it. So while getting the 3 set bits cost, okay, here bunch of different possibilities that are there. Okay, 111 for these 3 set bits. 111 is something what the mask that we have, right? 111. So here different possibilities we can have. What are those possibilities? It can be like AB or AB and BC. That is one possible combination from here. Okay, that is one possible combination. For A, we already have the answer. The cost is basically 0. For BC, we just recently generated those costs. Okay, next possibility is like B and AC. Okay, that is also another subsets, like B is subset of this one and AC is also subset of this one. Next is like C and AB. Okay, that is another possibility. Now apart from this, do you see anything? Do you see anything? It is not right. Like again, I don't want to see, perform that operation B, C and A. So there we can strictly stop generating those solutions. Like we can perform puring there, whatever these things. Like once we are done, we don't want to grow. I mean, we want to get answer from here, here, and here, and once we are done, like we are simply done. Okay, so the puring is something what we can perform there. So this puring, and for this one, like we can run another for loop, and we are trying to generate all different subsets. Okay, so this is our mask 111. So we will start from 1 all the way to whatever this mask that we have. Okay, 3 is the, I mean, this mask is basically 8, right? So 8 divided by 2, so till 4, like different mask we get it, right? Like 0, 0, 1. Then next is like uh, what is that? It is going to be 0, 1, 0. Next is like 0, 1, 1, and lastly 1, 0, 0. So these are 4 different possibilities. These are 4 different masks we will iterate. After that, we are not going to again iterate for 5, because for 1, its replication is like 5, 1, 1, 0. Okay, so we will simply run from this mask, like from 1 all the way to mask divided by 2. Till that point in time, our second for loop runs, and we will simply just check that whether this is a subset of this 111, whether this is a subset of this 111. If it is a subset, what is its relative opposite pair? Okay, because if we are considering A as a subset, obviously the second subset, okay, which is when we union them, the entire result is something what we are getting it, which is going to be BC, is something what we have to get it. And for this BC, we already generated the cost for this two. Okay, for AB, AC, BC. That's why we are simply running it from the set bits, right? Like for 2 we generated, for 3 we generated, then for 4 it is obviously going to be different possibilities, right? Different possibilities that we can get it. So those different subsets union is something what we are trying to get here. Okay, so that is the end goal. Let's write down that code now to get the cost, best minimum cost, and we are done. Now what we can do is we can simply maintain another cost array, which we can name it as cost new long. Here it is going to be mask. Okay, so till the mask, whatever results, different results that we are getting it, it is not a mask, right? Like what I have named size. Now size is something what we have. We'll run a for loop for int set bit equals to, from 2 we are running it, right? Set bit uh, set bits. Okay, set bits, let's name it as set bit only. So it goes all the way to n. Okay, and lastly it is like set bit plus plus. This is our outer for loop. So from 2 we are going, and we'll get all different masks that are available for this set bit 2, then 3, 4, then 4. So this another loop is like for int mask, from this bit to mask, just provide here set bit. So all different AB, AC, BC, those masks we get it. For those masks we will simply calculate the cost. So int cost equals long dot max value. Initially max value is something what we can consider for the cost, because minimum is something what we are looking out for. Okay, so now the cost is something what we have. So let's run a for loop for int I equals 1. Okay, I less than this whatever the mask that we have divided by 2. Okay, I already explained, like we are just stopping, avoiding to again just retry all different possibilities. Like if A and BC is something what we have solved, then BC and A is something I don't want to solve again. Okay, for that, like we just ran half of that particular mask that we have, and let's look for A, whether a particular list A means like whether first list is a part of that mask or not. Again same thing, it should be a subset. Okay, it should be a subset. When we add I mean when we perform AND operation between them, result should be A only. So for that, what we do is basically A and mask when you do, if it is giving us A only. Okay, how? Like let us suppose we have mask 111, sorry, 110, and A is basically 100. Okay, so when we perform AND operation, obviously this results A itself 100. Correct. When you perform AND operation, you simply see that, right? Like rest all digits become 0, and A itself is answer that we are getting it. But again, like if we have this particular mask, okay, when we are running from this, Let's suppose this is the mask that we got it. That is going to be our A or I. Here it is I. Okay, sorry for that. It is going to be I. So this is I. So yes, this value I, if let us suppose when we are iterating and we got that particular mask, okay, while iterating to that one, and if when we perform this AND operation here, this value is going to be different, which is not equals to I. Whatever this value we have, which is not equals to I, that means this particular subset is not part of this mask. That's how we can get it. And we are just simply trying to see if that particular I, if it is a part subset of this mask. If it is a subset, obviously other subset is something what we are looking out for. So if this I is there, so let's get J, which is like whatever I we have, and mask when we perform XOR operation, we are simply going to get J. Okay, so these bunch of different operations, you should be having clarity what we are trying to do here. Now both I and J, we got it. Now we just simply have to calculate the cost. So cost equals math dot mean between this current cost or cost of I plus cost of J plus length, total length of that mask, whatever the mask we have. And next is like obviously math dot abs of median of I plus median of J. Okay, once we are done, like we got the cost of AB or BC or anything like what we are trying to look out for. When we get the cost, we will simply update here in this cost area, cost of whatever the mask that we have for that particular mask. Okay, we got this cost. Right, now at the end we simply can return this particular cost of size minus 1. Okay, let's see if it is working fine or not. Okay, there are a bunch of errors. What is that first one? Bit to mask. Okay, here em got small. What is the next one? To map. Okay, map to, I think that is map to, right? Map to. Let us see if it is working fine or not. Okay, again there we have this problem, right? Arrays dot stream list dot arrays dot stream list dot map to. What is saying? Now L tends to L dot length dot sum. Okay, yeah, sorry, I think I just checked, it is map to end. Okay, I forgot this. I generally don't remember these stream APIs. So we are just trying to get the entire length of these different lists. Okay, nothing else. Map to end, and then we sum them up. Now next error is like line number 21, mask. And here bad operation means like we have to use here this one. If it is not equals to 0, then we are performing that particular thing. Let's see if it is working fine. I hope that was the last error that we have. Okay, bit to mask here also, yeah, I'm sure the capital. And what else? I saw so many errors again for the bit to mask. What was that? Bit to mask of sorry, it should be get, right? From this bit to mask, sorry, it is an array. So from that particular set bit to mask of that particular index. Okay, we are just getting all those array list data. Okay, loss couple, it should be long. I don't know, like I mean while speaking also, if I start solving, and these problems will be there. All right, let's see here. Cost of I. Okay, it is a cost of I, again cost of I, length abs median, required long but found okay, that is fine. It is long, right? All right, all cases are going wrong. What is the answer? 28. We are expecting 20. Cost of this one, length of mask, method median of I plus median of J, and then we are updating it. Correct. So let's start taking from start point. Okay, let me just quickly check where I went wrong. I think like here it should be minus. Okay, sorry, all these different issues. Let's see if it is working fine or not. Okay, it is getting accepted. Let me submit this code as well. If we discuss about time complexity, see, here we are having this mask, right? So it is like 2 to the power of n. Again, we are running this another for loop, which is the n times it is running, correct? So once we are done, like it is like 2 to the power of n cross n, and inside there again we are having this list through which we are iterating the entire length, whatever different list that we have, those combinations we are having here. So total length cross 2 to the power of n is something what we have seen here, and okay, and again we are sorting that data. So whatever length that we are getting, if m is the length, so m log m is something what we can say in all total all. So 2 to the power of n cross m log m. Okay, so once that is done, again like here we are running set bits, like how many set different set bits that we have. Then this another for loop, we are running it so to get all those different possible set bits, I mean mask that we have, and we are running half of that particular mask, whatever the mask that we have. So again like if I mean to the power of n mask we are running it here also, halfway also we are running it, but still it is fine. Like in overall 4 power n is total complexity that we get it. Okay, yes, like we can decouple these and we can easily explain like where what things it is taking and all. That is fine. So this is how we can basically solve this question. If you understood, please make sure to like this video. Thank you for watching this one. Bye bye.